Hello students, I am Talika Banerjee. Today I bring you a learning module which is Restoration of Erased Numbers Part 2. In this lecture we will discuss about practice of number restoration, chemical methods of restoration, reagents used for various methods, electrolytic and ultrasonic method of restoration. We will wind up this module with a discussion on other methods of restoration. Dear students, recall that in the last module, which is Restoration of Erased Numbers Part 1, we discussed about theory behind number restoration and methods used for removal of serial numbers. In addition to it, you also got to know about the non-recoverable methods of number removal. Let's start our module with a look at what we are going to learn today. First is practice of number restoration, chemical methods of restoration, reagents used for various metals, electrolytic methods of restoration, ultrasonic cavitation for restoration, other methods of restoration, and then we will conclude with a conclusion. Starting with practice of number restoration. First is surface preparation. As a part of the number restoration procedure, the surface must be treated to reveal the crystalline structure of the metal, and hence it becomes necessary to polish the surface as a preliminary step to the recovery process. This is the best accomplished by first removing all scratches and other gross marks with fine emery paper. This is followed by a final polishing to a mirror-like finish like jeweller's rog or flow paper. After polishing, the surface must be degreased and cleaned with chloroform or acetone. Chemical etching method for restoration. The chemical etching method is the simple and the most effective method for restoring obliterated numbers. It is simple to apply and it requires no expensive equipment. It works well on any size or type of object. The techniques involved requires considerable skill and patience. The materials used are potentially dangerous and should be used with full awareness of health and safety requirements. They should only be used in areas especially set aside for this purpose. When using corrosive acids and volatile liquids, rubber gloves should be worn to protect the hands. In case laboratory conditions are not available, work should be carried out in open air away from any seat of naked flame. When examining a motor vehicle for the purpose of restoration process, the engine should be removed carefully so as to easily access the number surface of the engine. This will also help in acquiring better quality photographs for restoration process. Preliminary examination. The metal surface is cleaned with the help of acetone to remove oil and dirt. It is then examined for any erasure by a hand magnifier. The surface is then looked for any disturbance at the background. The pattern present on the surface will either be in the form of milled marks produced by grinding the surface before the serial number is stamped, or cast marks from the process of manufacturing. If any disturbance is seen, erasure can be suspected. If no erasure has been noticed, a part of the wide area is removed to ensure if the area carrying the chassis number was removed, either by substituting it with pasting a metallic plate or welding or by cutting. In case any pasted metal is present, then it is removed with the help of trifluoroethanol from the original surface after the original appearance has been recorded. The welded plate is too removed after this. Next, the lower surface is also examined for obliterated marks. In addition, it has to be noted that how erasure has been done and whether it has been repaired or not. The surface is also checked for the visibility of digits and these are noted down. Moreover, the surface is also examined carefully by adjusting the oblique lighting such that the erased number is easily visible. For the purpose of photography, a single light is used for striking the surface comprising the serial number at low angle. Also, the light is moved at each instance such that it strikes the surface from a different position and various exposures for it can be obtained. Process film is used such that this method assists in bringing out the faint serial numbers. The type of metal from which the object is made is then identified. This is necessary to choose the appropriate chemical etchants or the chemical etching solution. Next is preparation of surface. The surface is cleaned usually with acetone or benzene to remove paint or grease. For this purpose, solvents, for example commercial paint remover, gasoline and mixture of acetone and chloroform in the ratio of 50:50 can also be used. A soft toothbrush can be employed to dislodge deposits from the stamped surface. The area is hand polished to a smooth mirror-like finish, or this can also be done by an emery cloth or other fine abrasive. To remove gross marks and all scratches, fine emery paper is used. Removal of metal should be carried out according to necessity while leaving deep scratch marks. During the carrying out of polishing, the surface should be examined because digits are sometimes revealed during this process. The surface is again cleaned with a solvent, for example acetone. It should be noted that the surface should not be touched with bare fingers or bare hands because deposition of fingerprints on the surface can interfere with the reaction. Next is heating. The area is treated using Bunsen burner or a blow lamp, but care should be taken not to overheat the surface. In case the metal is heated to red hot, the temperature is adequately so high that it will soften the metal, and on cooling the metal turns homogeneous and hence cannot be differentiated. A useful guide is to heat the metal surface until it is just too hot to touch. The metal should be allowed to cool before etching begins. After this, the entire object is photographed and the details of the obliterated area are recorded by close-up photography. For the purpose, a 35 mm camera comprising a macro lens extension and a fast film of 400 ISO is used. The usual methods required for chemical etching remains basically the same for all metals, though different chemical formulations are employed for each. Basically, the reagent is applied to the polished area with a cotton wool swab with a rubbing action. After approximately 1 minute, the reagent is rinsed off with acetone and viewed. The number should begin to appear as a shadow, which is often best viewed with oblique lighting. If nothing appears after 1 minute, the process is repeated for consecutive intervals of 2, 5 and then 10 minutes for a total of 2 hours. The application of sufficient heat to make the surface hot enough to just be able to touch not only speeds up the development but also appears to enhance the result. Next, we will be studying about the reagents used for various metals. There are a list of etching agents for various metals and it is endless. Nichols' book on forensic science lists a number. Hatcher, Jury and Weller in 1957 recommend Fry's reagent, as does Matthews in 1962. And a number of very useful reagents are listed in the Journal of Institute of Metals, number 1915, volume 13. Probably the most authoritative work on the subject was carried out under a NASA contract, NASA Lewis Research Center in 1978. A very large number of reagents are listed and covers all aspects of number restoration. Some of the popular reagents have been told over here. We will first start with iron and steel. The very first reagent is the Fry's reagent, comprising of 90 grams of cupric chloride and 125 ml hydrochloric acid in 100 ml water. After applying the solution, as I have already told you, the area is washed with acetone and then treated with 15% solution of nitric acid. The process is repeated until a number develops, and that can then be photographed. The next reagent is a combination of 5 grams of cupric chloride, 40 ml of hydrochloric acid, 25 ml of ethyl alcohol and 30 milliliters of water. The third reagent here is 5 grams ferric chloride, 50 milliliters hydrochloric acid in 100 milliliters of water. The fourth is a saturated solution of picric acid in ethyl alcohol. The fifth solution is of 40 grams of chromic acid in 50 milliliters of water. The sixth one is 1% nitric acid in water. Of these, probably the most widely used and successful is Fry's reagent. Next is for aluminum and aluminum alloys. The very first reagent here is Villela's reagent. It is probably the best reagent, but it is extremely dangerous. And the composition is 30 milliliters of glycerine, 20 ml of hydrofluoric acid in 10 ml of nitric acid. The second reagent for aluminium is the Hume-Rothery reagent, which is not quite as efficient as Villela's reagent, but it is much safer. And the composition consists of 200 grams of cupric chloride, 5 milliliters of hydrochloric acid and 1000 ml of water. Fry's reagent can also be used on aluminium and its alloys, but care has to be taken as the reaction is a little rapid. The next is for zinc and zinc or aluminium alloys. First reagent is 50% hydrochloric acid followed by 50% of nitric acid. For brass, it is 40 grams of cupric chloride, 150 ml of hydrochloric acid in 50 milliliters of water. The second reagent or the etching solution for brass is 19 grams of ferric chloride, 6 milliliters of hydrochloric acid, 100 milliliters of water. Electropolishing is a process where the specimen is made the anode in an electrochemical cell. When the current is applied, minute irregularities in the surface are dissolved, leaving a highly polished surface. As the electrical properties of the stamped area are minutely altered due to the compressed crystalline structure, the dissolution of the compressed area will be different from that in the non-compressed area. This was first developed about 25 years ago and has proved to be a successful method for serial number restoration. As we know, the specimen is made the anode and a cotton swab containing the electrolytic solution becomes the cathode. An external variable DC voltage is applied and adjusted to be just greater than the minimum voltage necessary for the current to flow. This is called as the critical voltage. For a steel, the critical voltage is approximately 6 volts. For brass it is 7 volts and for aluminium it is 7.5 volts. Next are the reagents used in case of steel. The very first reagent is 1 gram of cupric sulphate in 15 milliliters of sulfuric acid. Added to it is 1 gram of gelatin in 500 milliliters of water. The second one is 5 grams of cupric ammonium chloride in 50 milliliters of hydrochloric acid, and to it is added 50 milliliters of water. For surface such as aluminum, first reagent is 17% sulfuric acid and the second one is 2% fluoroboric acid. Next students, we will be studying about the ultrasonic cavitation for restoration. Cavitation is the formation of vapor bubbles in a liquid due to much localized reduction in pressure. This can be observed in high-speed motorboat propellers where a stream of bubbles is created. The phenomenon is very similar to boiling where bubbles of vapor are formed due to localized increase in temperature. Any metal object which is subjected to this cavitational effect will be surface etched. In pumps, high-speed propellers and pipes carrying high-velocity liquids, this can be extremely troublesome. The technique of surface etching under the controlled conditions can nevertheless be used for restoration of erased serial numbers. If we talk about the method, if a high frequency electrical current commonly of 20 kHz is delivered via a piezoelectric transducer, the electrical current will be transformed into mechanical vibrations of the same frequency. Hence, the introduction of these mechanical vibrations in water, either with the help of a probe or by some secondary technique, will result in vibrational cavitation of water, which is also known as ultrasonic cavitation. The specimen is simply placed in the stream of cavitation bubbles. Visualization of the erased number occurs as a result of the cavitation removing less metal from the stamped area than the non-stamped area. This is probably due to the stamped area becoming work hardened due to compression of the crystalline structure. This work hardened area being more resilient than the surrounding area is more resistant to cavitation. The method has the advantages of being applicable to all metals and to require the treatment with any chemical reagents. Heating with an oxyacetylene torch to tint the surface has been reported as has been heating the object in an inert atmosphere called heat etching. Neither technique has found any degree of favor. Cooling the object until water vapor frost forms on the surface has also been reported. This has not proved all that very successful. Electroplating, the opposite of electroetching, has also been suggested, but once again it is rarely successful. Other more esoteric methods under review or development include electrolytic etching, hardness profile measurements, relief of polishing, X-rays, that is transmission, X-rays and reflection, scanning acoustic microscopy and electron channeling contrast. Of all these methods, the most simple and most efficient have been found to be the chemical etching. It is quick, simple, does not require any expensive or bulky equipment, and the results can easily be photographed. Of all the reagents, Fries is probably the best for steel. It can also be used with care on virtually any other metal. Next, if we talk about the magnetic particle method for restoration, it is a standard method for the visualization of minute flaws or cracks in ferrometallic objects. That is to magnetize the object and then spray it with magnetic particle dust. Any flaws or cracks in the metal are indicated by an accumulation of the magnetic particles. Once again, this is due to a change in the crystalline structure of the metal around the crack or flaw, giving rise to an altered magnetic property. The magnetic particle dust is available commercially either as a suspension in oil or water or as a dry powder. Application of this process for the restoration of erased numbers is a standard method and has been the subject of a number of papers. The great advantage of this method is that it is a non-destructive technique. It may therefore be tried before attempting any more damaging technique of restoration. If we talk about the specific method, the simplest way to carry out this technique is the attachment of a large horseshoe magnet with the object, thereby keeping the erased portion in between the poles. The area is then sprayed with the magnetic dust and any excess is gently blown off. Practice in this area has shown that the most effective method for application of magnetic dust is to spray it with the dust suspended in an oil suspension. These oil-based suspensions are available either colored or with a fluorescent marker, both of which are very efficient. The method will only work with ferromagnetic metals as the material must become temporarily magnetized. Stainless steel, although non-magnetic, can sometimes work with this method. It is believed that when stamped, the stainless steel work hardens and becomes slightly magnetic. This faint magnetic property in an area which is non-magnetic is often sufficient for a restoration. Today, criminals are inventing new techniques by which they will not get caught after commission of crime. This does include the removal of identification number present on firearm and other materials required for the purpose of individualization and characterization, and hence as a result of this, restoration of serial numbers is very necessary. As a part of the number restoration procedure, the surface must be treated to reveal the crystalline structure of metal, and hence it becomes necessary to polish the surface as a preliminary step to the recovery process. In addition to this, depending on the type of metallic surface, certain specific chemical reagents are employed for the purpose of restoration, such as Fry's reagent used for iron and steel, Villela's reagent and Hume-Rothery reagent for aluminum and aluminum alloys, etc. Apart from these, there is electrolytic method of separation wherein the specimen is made the anode in an electrochemical cell. When the current is applied, minute irregularities in the surface are dissolved, leaving a highly polished surface. Also, some other techniques used for restoration includes heating with an oxyacetylene torch to heat tint the surface has been reported, as has heating the object in an inert atmosphere, called heat etching. Electroplating, the opposite of electro-etching, has also been suggested, but once again it is rarely successful. But one thing which needs to be looked in for is the type of metallic surface for which the specific restoration procedure is being carried out. With all these information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. This is time for your self-study. If you want to learn more for enhancing your knowledge, you may log on to our website www.cec.nic.in for MCQ, quiz and LORs. Till then, keep studying, stay connected and goodbye.